Alex is the co-founder and CEO of Natrion. This is not Natrion, it's not sodium ion, it's Natrion, which is a solid-state electrolyte separator. And I'm going to let you talk about yourself a little bit and your company and your product.
Yeah, thank you, Sama. Thanks everyone for being here. Really good to see some familiar faces. Hope you're enjoying the Deep Tech Week. I'm Alex. I'm co-founder and CEO of Natrion. There's a few companies similarly named as us. We're the ones out in Illinois and New York. So I study material science at the University of Illinois. We got some fellow alumni out here, awesome. And we're still actually out there. We've got our R&D still in the research parks out to campus in Champaign, and then we have our production facility in upstate New York in Buffalo. We make a solid-state electrolyte separator and a few other.
Apparently, Aaron got here on time. Come here, Aaron. This is Dr. Aaron Wade, our other Sterno Spotlight. Yeah, you made it.
Sorry for being late.
You don't have to listen to my scratchy voice anymore. Awesome.
Cool. At least I'm not the only one. Yes. So I'll just finish up real quick and I'll hand it over to Aaron. But and so we've raised about $8 million in seed. Now sort of ramping up our production, trying to meet larger volumes for a few of our key partners and customers. With our separator product for lithium ion, lithium metal, lithium sulfur cells, we've got a few pretty interesting value propositions there. But over to you, Aaron.
Cheers, everyone. Sorry for being late. Just ran over from the airport. My name's Aaron. I'm from a company based in London called Gussian. And what we do is we add magnets to batteries to enable them to charge 6 times faster or last 8 times longer. So it's completely agnostic to the chemistry within the battery or the form factor or anything like that, different applications. So you can apply this to EV batteries, stationary storage batteries, drone batteries, whatever it might be. And using magnetic fields, we can essentially enable more homogeneous transport of the lithium. Then you reduce the resistance, you can pump the current up without having a massively negative impact on the cycle life.
Cool. While you're catching your breath of this, we're supposed to ask each other questions. And so, Aaron, we'd just love to learn more about your tech. Can you tell us more about this sort of drop-in aspect of it? I mean, are you coming in at a system level, module, cell? And what does the integration look like? And for the OEM, what are some of the barriers, or maybe there aren't any barriers, right? Can tell us more about that?
I think the biggest barrier so far is nobody believes us, which I think is fair enough. The claims are pretty big. So a lot of our work to date has just been doing cell level testing. So people will send us cells, or if the cells are super secret, they'll give us similar cells. And we'll do A/B testing, so same temperature, same charge protocol, same everything, but one in a chamber with no field, and then one with our devices to make the field. So that's most of our work, and then we've done some pack build out. So we've got a prototype BB pack without cells, but with all of our tech in, and now moving more towards the module stage. It's very thin light components, so we're hoping the integration isn't too bad. But I think there'll be a lot of challenges when we actually come to playing around with it. But cell level for now.
So it's really cool. And so, it's so fascinating. And how did this get developed? What's the story behind this technology? If you can speak more.
Yeah, so it came out of University College London. So our two co-founders used to spend a lot of time at synchrotrons, so particle accelerators, where we did lots of X-ray imaging of materials. And at synchrotrons, you use giant magnets to control the beam, and then that changing direction of the beam is what you use to image. So then they thought, if you can do this and control ion movement with these massive magnets, can you miniaturize them and then start to apply that? So they first started looking at doing that in fuel cells, then realized batteries are way cooler, so then moved over to the battery side of things. Which I guess brings me nicely to a question I had to you, which is, when we spoke yesterday, you kind of told me of the journey of pivoting around and kind of finding where you should sit in the space. So interested to hear kind of the thought process and the challenges on that side of things.
Yeah, Natrion, we've been around for a few years now, and as our name suggests, we did not have our start in lithium batteries. We did, in fact, try initially to commercialize a sodium battery tech that we developed, and we're licensing out of academic research, right? And very quickly, sort of, ran up against the wall of the great big incumbency of lithium ion and just, the economies of scale of lithium ion, which was difficult to go up against, principally because, the value prop for our tech was sustainability and a bill of materials cost reduction, right? And also because the nascency of sodium ion, I'm talking about between 2018 and 2020, we worked on this, meant that we would have to make the whole cell, which is an exceedingly difficult task. And one fraught with cautionary tales. So during COVID, we made the pivot. Our original sodium technology had a solid state electrolyte component to it, and we knew of lithium analogs of the material, and so we went through an in-house process to then see, okay, can we make this into a form that's going to be useful for lithium ion and sort of next gen lithium chemistries. And one of the gaps we saw in the market was there really wasn't a lot of separator providers, especially within the US. And so we said, okay, can we make a new, better all-American separator product where the benefits are coming from us making it out of solid-state electrolyte, and that's really what our product is.
And I guess what stage are you guys at? Unless you already covered this much there, sorry.
No, not yet, thanks. Well, I mentioned we just spun up a new manufacturing facility in Buffalo. We're going to be making a big announcement soon, but yeah, and I'm quite excited about this capability. And today we can, fully ramped, we're going to be able to service about 100 megawatt hours of cell production, its initial iteration. And then going to about half a gigawatt hour, hopefully, in the next sort of 18 months or so. So our turn to do the production hell, but yeah. Yeah, and I'm sorry. So, yeah, my question for you as well, I mean, what's next? I mean, congratulations first off. If you're unaware, Gussian raised a pretty significant round. And so just curious, I mean, what are going to be the milestones? What should we look out for you? What's next? What are you going to be accomplishing?
So I guess the long-term goal is EVs, but obviously that takes a long time. So what we're focusing right now is doing the work with our EV partners, but then in parallel looking to get into smaller applications early. So we've got Tesla cells ongoing and starting to do module designs for that. So the goal is to roll out or get data in these kind of more niche applications and then build that out. So we just moved into a new testing facility, so now we can build packs. We can drive the vehicle in, drop the pack out, put our own pack in, drive that around London. When I can't drive, so I wouldn't be doing that part. But someone in the team will be doing that. So that's the goal really, is get some data, get it out there, and then in parallel keep working with the OEMs to hopefully get it in every vehicle.
Fantastic. I mean, really, I think all of us are really hoping for your success with this. Do you have any advice, perhaps even for founders like me, right? This is Deep Tech Week, and we're in San Francisco, the VC capital, right? And when you have a battery play where obviously the biggest market might be, or is likely EVs, I mean, how do you tell that story to investors who, frankly, they need to make a return, right? And you're talking about long sales cycles, especially for sort of a component or retrofit technology like yours. What is that narrative, and how did you shape it and be successful with your fundraising?
I wish I could take any of the credit, but they raised before I joined. So I don't know about the previous round. I know what we're doing moving forward, which is big end markets. But then our tech is also and can be used in both current and next gen materials. So I think it has maybe the most interesting play if lithium metal ever becomes real, with the ability to stop dendrites forming. So I think that's a big story, is what are you doing today, but then maybe where do you go? And I guess on our side it's a bit easier because we're not changing stuff within the cell, which I guess maybe is a challenge for you. How do you work with cell makers to convince them to adopt what you have?
Yeah, I mean, no simple answer for that. I think we're still figuring that out. Yeah, in our experience, there's no such thing as a small there's no, Yeah, no change is a small change, right? So, any kind of vendor qualification is a whole undertaking for any OEM, and we just have to be mindful of that. And we're a small startup with no manufacturing track record, so I got to lean into the value proposition and what we can offer now and in the future, like you said. I think, are we good on time, or just about out?
No, it's fine. Yeah, that's it.
Okay. Thank you very much, everyone. Thank you, Aaron. Thank you. And enjoy the event.
Awesome. Thank you so much. My name is Sama. I'm founder and president of the Battery Saloon. I am a mechanical engineer by training, but I've never worked as an engineer. I've always been a research scientist, product manager, stage actor, and stuff like that. So yeah, nice to meet you and see your faces. So I'm not gonna talk too much. I'm gonna let people introduce themselves. So we have Celina.
I am Celina Mikolajczak. Despite my lack of ability in finding parking in the city, I'm an engineer. Had a very misspent career. I've been doing batteries about 25 years. I started in failure analysis at Exponent. I ended up getting hired by Tesla when the Exponent stuff started getting boring. And that was right before we launched Model 3, or Model S. So I joined the company and was there through the Model S launch and ramp, and then stayed until Model 3 started to ramp, which was about 6 years, which seems short, but it's not in Tesla years. And then I went and joined Uber and designed battery packs for the Elevate program, which was aircraft, air aviation, and then bicycles. And I still see the little Lime bikes with the packs my team designed on the streets, which is awesome. And then I went to Panasonic and the Gigafactory, and I ran engineering there, and we shipped 2 billion cells during COVID, which was really fun. Me and 4,000 friends keeping the factory running. And then came back to the Bay Area, spent some time at QuantumScape, and now I've been 3 years at Lyten. And we're about to commercialize our first lithium sulfur cell. So that's me.
So, thank you. So a couple of more things about Celina. Celina wrote the book Lithium-Ion Batteries Hazard and Use Assessment. Is that right?
Oh, yeah.
Yeah.
That was a long time ago.
Yeah. I mean, you look 18 to me. I don't know what you're talking about. And she was on the list for Business Insider's 2022 top 100 people transferring businesses.
Ooh.
And named by the Silicon Valley Business Journal as one of the women of influence for 2022. And in 2020, Celina was also named to Automotive News as 100 leading women in North America.
Yeah.
You just forgot them, so I wanted to complete the introduction.
Yeah. Good. Fair.
Yeah, awesome. Thank you so much for being here with us. Appreciate it. Asma.
Hi everyone, I'm Asma, and thank you Sama for inviting me and being a part of this amazing panel. I have worked in the battery industry for a decade, mainly worked in advanced battery technology. I was interested in automotive in general, and the passion started from when I got to be 18 years old, learned to drive, and I started racing in the streets of Iran. And that was my passion, to learn and become into automotive industry, and the pathway to enter that was through electrification. I joined Core after graduation and work on technology scouting, mainly looking into the advanced battery technology where we can create synergies between the lithium-ion battery and the next jump that will help with the safety, energy density, and sort of address the concerns of the customers who are mainly having the range anxiety and the safety that is one of them. After that, joined Rivian, being a part of the journey, and that from there work on the lithium metal batteries at Cuberg, working in aviation, making a little pivot of finding out how the automotive and eVTOL can be utilizing the batteries that are providing the high discharge rates and also the really significant energy densities that are available. And from there now, I am in PowerCo US as a CEO of the company, building up the company and also trying to build the partnership that we have with the Quantum Escape in order to take the technology that the Quantum Escape has developed over the course of 12 years into market by commercialization of the technology and finding out how we can have benefit from these safer battery technologies into an automotive industry. That's me, and looking forward to getting to know all of you as much as I can today.
Awesome. Fun fact, for the longest time, people were confusing me and Asma on LinkedIn. And I was so happy about it. Keep doing it. Also, welcome to the panel. Kenzo. Finally, we got Kenzo in here. I've been trying for almost how many months? 9 months.
Okay, sure.
Yes, I did it.
Apparently, yeah, you've been waiting 9 months. So my name is Kenzo. I've been in the lithium ion industry for 30 years now. So June of 1995, 30 years ago, probably this month, I started in a company called Sama Aghniaey up in Canada. We were competing with Sony on the 18650 level, and it was a 1 amp hour cell. Today it's more like 4 amp hours, so you can imagine the progress there and the dangers and risks and fun that comes with it. But spent 14 years at Sama Aghniaey, from an engineering tech to an R&D sort of tech, and then a quality reliability sort of lead, making sure the things that get shipped wouldn't affect the customer, and also doing forensics for field returns. I've had to dissect my fair share of melted laptops and melted power tools, so I know all the things that can go wrong in manufacturing, I think. From there, Celina hired me at Tesla, and we spent some time looking at Gigafactories all over the world. I see some faces here where I helped design the eventual Gigafactory that Celina ran, but I didn't want to move completely to Reno. My family didn't want to move to Reno, so I stayed in the Bay and worked on a project at Apple. It's a project that I cannot tell you about, but I figure it's probably the worst kept secret in the Bay Area. I did that for 4 years and moved back to Canada again to Sama Aghniaey to help design their Giga facility. But COVID occurred and federal funding dried up. So I found myself doing sort of an EPC role for a little bit. I was at Northvolt for a little bit, and for the last 2 years I've been doing consulting. Now I sit on 9 different advisory boards. I support about 10 different battery companies, mix of software, hardware, material, half in Japan and half sort of here in the Bay Area. But nice to meet you all, and thank you for having me.
So we thank you for being here, Sheds.
Okay, my turn. My name is Hoitu, and I'm a material scientist by training. I graduated from Carnegie Mellon and with material science in there. And so after that, I worked at the semiconductor industry for a little bit, and then I turned to Zion Power, which is located in Tucson Desert. So far, it's been there for 12 something years. So it's an interesting journey, actually. In 2014, actually, me and my partner, we started a company called MSC Supplies from nothing. We didn't raise any money, pretty much. We grew that to $100 million company the worst day, right? So last year, we successfully exited last year. And, of course, at the same time, while we're running that company, of course, we survey a lot of the big factories, and we saw that gap in the solid state battery kind of at that time, especially 2017, there's a large gap of the material supply, which is a critical material for solid state batteries. So we had that as Travis kind of background. We had the unique kind of scaling capability back then. That's why we started Ampcera back in 2017. And at the beginning, we thought it would just be a material company, but in the end, all the customers pretty much forced us into building some batteries and develop the battery technologies in-house over time. Right now, we have kept that small team, but we solved a lot of the key fundamental issues in solid-state batteries. Right now, I think we're on the edge to scale from prototype to commercialization at this stage. Yeah, it's very nice to do. And then I really like the vibe here at the Bay Area. It's very unique and precious. Thank you so much.
Sometimes they have sun too. Not really, sometimes. But Ryan is one of the people that really both academia and industry, like 30 papers, journal like peer-reviewed papers, like 50 patents. And fun fact, he always responds to emails and says, confirmed, I received. Awesome.
Try to.
Things that I don't do, but I appreciate it people do. Awesome. So thank you so much. Thanks for being here. One question I want to start us up with is the battery industry is very difficult. Building batteries is very difficult. Scale is very difficult. Why are you still in this industry, and what motivates you to get up in the morning and still work on batteries?
It's hard. And I glutton for punishment, I think. You, as an engineer, you want to do something that's meaningful, right? You want to do something that matters. You want to do something that changes the world for the better. That's why you became an engineer, right? And if you look at what are the big problems that we're dealing with in the world, I don't know, that changed a little bit over the last few months, maybe, or 6 months. But, you know, when I was at Tesla, and ever since then, I realized that defining problems for our age is climate change, regardless of whether people think it's fashionable or not. This is the thing that's going to impact all our lives and all our kids' lives. And, when you look at study history, and I like history, if I hadn't been in engineering, I'd probably do history. I don't, that'd be weird, but whatever. But I love looking at history. And when you look at periods where the climate has been impacted by, big volcanic eruptions that really disrupted the way people lived, you ended up with big wars. People, when the resources start disappearing, people start fighting each other for the resources, and that's not a really great place to live, not a great world at that point. So, if we want our world to be prosperous and peaceful and all our kids to have great futures, we have to address climate change, right? A lot of ways to do it. For me, I do batteries because I think that when we electrify everything, we're actually going to be able to move the needle on climate change, okay, and have that prosperous society. So, it's very missional, right? But that is why I get up in the morning and keep doing this because, as you said, it is incredibly difficult and frustrating. And you think you know the science, and then you don't know the science. You think you know the engineering, and things don't go out the way you want. And there's never enough funding, and there's never enough money. And it's just really, really hard. But, what else are you going to do? You're going to, do something that's not so meaningful? Do batteries.
You're not doing batteries. Get out. Well, along the line what Celina mentioned, global warming is something that is happening, it is impacting us, it's going to impact our next generations, and mobility is really defined on every part of our life that we look. There is batteries that we can utilize, that we can benefit from, not only vehicle, not only energy storage, for home energy storage, grid application, the instabilities that are happening, all of these hurricanes that are happening that are impacting people's life. By losing power, your life paused and your life is going to stop. So you need to maintain that. You need to have a sustainability. And with that, one of the main solutions is the existence of the batteries. And that's why all of us being here, I think we are part of the battery family. So we're trying to find out what is the right approach, what is that right chemistry. There's not one solution, and that's why I'm happy to see there are different chemistries popping up here and there. There are different startups, and I just hope there's going to be a right mindset with the right vision, with the right cross-functionality that come together, look at it from different angles in order to really take it to the next level. And I'm honored and I'm super happy that I'm a part of that journey throughout my life as I became more involved in the battery industry, just seeing all of the pain points that exist. A lot of it is connected to this continuity of the power that we can have. And a part of it is also the climate change is going to impact our life. I have a kid and I want to have a bright future for her. I want to be a part of the journey to create that bright future for her. And that keeps me motivated to wake up and say, challenge accepted, and go on and move and make sure that I can impact it in the right way. The failure modes are much more than success stories for sure, But, as engineers, I just say challenge accepted, and I try to find out what would be the different angle, the different lens to put on in order to answer and find an answer and then find a solution to the challenges that you are facing.
So all those things for me too. But beyond that, my first job as a full-time job, I got by chance. And then I stayed because I got my real first girlfriend there. So eventually she became my wife. So I'm blessed to be by chance going to some of these places like Tesla and Apple and these workplaces where it feels like I was supposed to be there and I'm supposed to contribute to this industry. And now I feel like I'm trying to help people who are trying to solve the problems that maybe I saw 10 years ago or 50 years ago and shortcut those things. I don't want anybody to disassemble 10,000 cells. I think I've done that. So there's technologies now that you can get insights onto cells that you don't have to dissect them all every time. So
I still have to dissect.
Oh, yeah. There's no substitute for
The prosecution. Which
but yeah, so those types of companies I like to support, and I feel like there's a lot of picking my brain on some of what did you do 10 years ago, or how did you solve this problem, and it's kind of the thing that I get up in the morning for is those types of phone calls where people really want to learn and really want to understand to it deeply, but maybe not have to go through the whole thing from the start.
So for me, I think it's when you see the impossible become possible, that's very rewarding. If you're a gamer, pretty much not a mission to wake up, probably you don't want to go to sleep, right? So, and when you keep, beating down those giants or whatever, you rescue someone, right? So in that game, right? So you feel rewarded. So I just remember, back in 2017, a lot of times, people talk about, it's impossible for all-solid state to work. So that even some people in the middle of the way and switch to semi-solid and the hybrid and stuff like that, right? So, but over time we keep doing that. We keep, improve the materials, improve the structure, the design stuff. We did make the all-solid state battery work right now. Actually, a lot of times the parameter actually is on par with the lithium-ion at this moment, right? A lot of times also, when the engineer, call me probably after work almost to say, we get the material to nano or something, achieve that. That's exciting. We struggled for quite several months. And finally we achieved that, it's really exciting. I'll just tell them, which restaurant you want to go, let's go. So that's rewarding. That's something to keep going. I know sometimes it's frustrating at this certain kind of environment with the funding, money, and all the stuff, right? So politics can be frustrating, but those part of the excitement and making the impossible possible. That's something I think it probably keep every one of us here to be excited and to keep going with that. Thank you.
Awesome. Yeah, I see a theme in here. Like, what you said is impossible. Let me show you how. That's the thing to take it. Awesome. So I have another question. I'm sorry. Tonight I'm asking questions. If I told you that scaling a new battery technology is harder than building a new chemistry in a lab, would you agree with that?
Oh, yeah. Oh, please. Okay. Look, having a nice innovation and everything, and you do it in the lab, and people have done this a lot of times, right? And this is where, you go into the lab and you try something and you make some coin cells and you go, look, it works, right? So many people have done that. Lithium sulfur, so many graduate students have been told to work on lithium sulfur. They make some coin cells, okay? But taking that to commercialization, oh my God. Not only have the tech right, but you have to have all the little details right, and it has to all be manufacturable, right? So that means we can't use all the super expensive stuff. Not really. Not if you want to make it actually commercially viable. And you have to work out all those little details. People think, I'll make a cathode. Great, I got a material. Oh, that's step one in a 100-step journey, okay? Then you got to figure out, okay, well, that cathode, how's that structured going to be? Not just the cathode particle, right? Because, you make a coin cell, people take a slurry, put it on a slip table with a doctor blade, they, press it, whatever, punch the thing. For a coin cell, it works great, nice. Now you got to make it so that it works in a slot die, right? So what's your spray dried particle like? Oh, how's that structured? You can spend years just optimizing spray dry, right? Then you're gonna put it on the slot die and you're gonna try and find the right coating parameters, and you're gonna figure out, how do you dry this thing while it's in motion, and how do you make sure that you get that very nice even coating, because you can throw something on there, and if you haven't figured out all the nice viscosity parameters on that thing, your coating is going to be thicker in some regions and thinner in others. When you put that in a cell, it's going to suck. Okay? Right? And that's just one electrode, right? And you just keep doing this. And then, things that you never expected screw up your electrode. Like, in graphitic anodes at Panasonic, one time we found that 3 layers deep in the supply chain, someone had done a leaching step from the natural graphite differently. Not badly, just differently. And it just left enough silica particles in that anode to entirely screw up our slitting blades, so that we're trying to produce and the slitting blades are going dull. And we can't change them out fast enough to keep up. It took us 6 months to figure out where the hell this problem was in the supply chain, right? All of this goes on, all of it, even with conventional cell making. And when you're trying to commercialize something new, you have to learn all those things. So, maybe not 10,000 cells, but you're gonna dissect thousands of cells. And it just takes a huge team too. Because you can do a, development thing on your lab bench, and it's a, professor and some grad students. Good luck, you're never gonna commercialize a cell like that. You're the guys who commercialize cells, it's usually casts of hundreds of people with all the different specialties. And that just starts the process, right? So commercializing, I view the hardest thing. New chemistry commercialization, the hardest thing in cell making. Followed only by becoming a cell maker, legitimately. That's the second hardest thing. That's my opinion. I don't know if anyone else thinks.
So I remember when I started my journey in batteries in industry, my first manager told me the fact that lithium-ion batteries are working is a miracle. And we're waiting for another miracle to make solid-state battery at any new advanced battery technology to work. And I took that in heart, and I was like, what is he talking about? And now I called him, I know what we're calling. The miracle is happening, and we just want it to happen every single moment for millions of cells that we make. And to your question, when we're making a gram of a material in the lab, and we have a controlled environment, we don't care about this most expensive equipment that we have. We don't care about how expensive it is. We don't care about the yield loss. That pressure is not there. As soon as you take the first step to go to a kilogram or megaton, that is when your batch-to-batch variability will be there. That's when little mistakes, little variation in traceability that you might not have in your process can have significant impact. And that is at the material level, let alone take it to the next steps and all of the complexity of the material that you have to have. Yield loss, cost effectiveness. And then you're talking about little mistakes in the battery production that can cause shorts, that can cause failure modes, that can cause thermal runaways that will be really catastrophic. And those traceability are really important as you're having different batch to batch, as you're having your electrode going to formation, and the expense of the material, that will be really important. And you will realize it as soon as you start taking your lab product to the much scalar material, when you realize my supply chain is not ready, my automation is not right, my equipment is having a lot of constraints that I didn't even realize. The process step that I was thinking I can optimize and I can automate is not the right process step. And it is not going to be something that I can do more and more and more of it with the right reliability. You get all of that done, and then you have your final cell, put it in the application. You never thought about the vibration, all of the conditions that battery is going to consider, and then it fails. Then you have the cells that are coming back because your customer is like, have you ever considered there is a welding and it's failing due to this vibration? You're not aware. And it takes, I don't know, all of us, a lot of people from different aspects, from component level, from material, from mining, from automation, the equipment design, and then the final user to work together, to educate each other, to be the stakeholder and all of the cross-functionality to come together to make sure we are aware of what comes next, what is the next step, what are you handing off, what would be the impact of it, and that makes it really difficult to take whatever you're having in a beautiful lab, in your glove box, controlled environment, clean, into the commercialization and transitioning it to a Gigafactory.
Yeah, I think additionally to that, the human factor, like a factory with 4,000 people, there's 4,000 personalities that don't necessarily jive and might want to do something different from one day to the next. And cultures too. So, the Asian copy-paste, the Asian copy-paste machine that went to Reno took, 3 years to become steady state. And that was copy-paste with hundreds of engineers coming to show them how to do it. So when a startup suggests that, we're designing a cell, we're building a Gigafactory at the same time, and we'll commercialize in 3 years, that's a tall order. So
For us, we're definitely not looking forward to that. Mass production. So that's why our business model is that we develop the prototype and then we partner with those that have tons of experience in the past, right? But one thing we want to make sure, of course, we need to keep this pain in mind. So when we develop the solid state, of course, the chemistry may change significantly, right? With these parameters and the pain in mind, when we design the process and the materials and the systems, we need to always keep in mind is that we don't cause too much more pain. So at the first 2 years, actually, we did try certain approaches, which is significantly different from traditional lithium ion, like a sintering, other stuff, But when we look afar, we ask the question, the elephant in the room question is, what the heck is going on in the end? So you're going to change too much, and then what about the yield rates in the end, right? So what about the manufacturing, that the energy consumption, all the failure rates and stuff like that? So we think about it. We try adjust our processes, so we adjust our systems so that we can be as close as to the traditional lithium ion using the casting, use dry electrode or something like that, right? So to be as close as possible to ease that future pain as we work with future partners on that, so that it won't be creating new pains or too much of changes and stuff like that sometimes need a dramatic kind of equipment reinvention or something like those things, right? That can cause uncertainty. So that's always in our mind, is that don't cause new pains, to just develop as close as possible with the kind of a traditional processing approaches, right? While you're inventing new chemistries, making solid state work. That's always in our mind. That's our decision making lets us also up at the same time. Yeah.
Yeah, talking about traditional manufacturing methods and legacy manufacturing, how do you think how mature our battery manufacturing is industry? Well, Celina.
How mature? I think the conventional cells the manufacturing methods haven't really changed. You're still mixing a slurry, you're still spotlight coating, and some of these things are similar, but much faster. I don't like it when people say it's an immature industry, because people have been doing this for a long time and put a lot of blood, sweat, and tears into it. There are areas that have areas for improvement for sure, like data traceability, data tracking, and companies that focus on that thing, I think are going to be helpful for the industry to become, I don't like to say it, but more like semiconductor, where there's standardization in communication protocols, inspection methods, because right now the cell manufacturers, they kind of do everything in their own bubble. They have their own kind of way of doing it, and they're very protective of it. But I think as far as the maturity goes, there's room for improvement, but I don't think it's immature.
Yeah, I mean, Kenzo and I have been through so many factories together, in so many different roles. And when I was working at Tesla and then again at Panasonic, I got to see like a lot of Panasonic factories and Sanyo factories. And you could see the early factories, and then you could see the more recent factories, and there are multiple generations. But you could kind of see the heredity of the tooling and the heredity of the approach, right? And there has been, considerable versions of these factories. I mean, I think Panasonic Gigafactory was probably their 7th version of factory or something.
2 of them burned down.
2 of them burned down. Yeah, well, not entirely, but there's some lessons learned, right? Yeah, and I mean, so and these guys have produced billions of cells, right, that all work. And so people go, oh, they're not as mature as semiconductor. I'm like, yeah, bullshit. Okay, these guys, they produce billions. But what does it mean when you have the better data stuff? It means you can push the technology farther, right? So your tolerances get tighter, your capacity goes up. You can try some little more aggressive things with like your coating. Can you go thicker, right? Really and consistently. Can you wind more consistently, tighter, so that the tolerance on the winding is better, that the tension is more controlled? All these things allow certain differences in your material science. It lets you push harder, right? So, and the other thing is, I've thought about this a lot because, I was at QS and thinking about solids, like separators and moving solid particles and other stuff, or solid pieces. Roll-to-roll processes, they are super efficient and super fast, okay? And it's really tough to beat them, okay? Pick and place machines, the linear stuff, it doesn't work like roll-to-roll. Roll-to-roll is amazing because what happens is you get to make a material and then you put it in this big roll and then you move the whole roll around, okay? And the fact that it's a roll, that outer wrap protects everything inside. And it's compact, and you can pick it up with, a forklift or some kind of a conveyance, and you can move the roll. And you can throw the roll into storage and buffer things, right? And you can ship a roll around. And it's super dense and super compact. And then you put it on a machine, and then, how fast you unroll that thing, that's your manufacturing speed, and you can make the roll bigger and everything else. There's, the battery industry has gone to these roll-to-roll processes and the flat dies because they let you do this at scale, and linear processes don't come close.
Just a little one to add. So the legacy manufacturing is something that majority of the manufacturing for the traditional lithium-ion battery we are utilizing. But it doesn't mean that we are not looking to the next step. Dry electrode is an example. We can definitely transition one part in order to keep it up, but then try to eliminate some of the cost, some of the sort of the footprint that is needed in order to lower the cost and be more sustainable. The other part that we're trying to work on is formation. Formation process is a pain. It requires a lot of casting, a significant amount of formation. You either try to optimize for the formation process, or there's going to be technology where it doesn't require that formation open. So these are that we definitely have to rely on the legacy manufacturing in order to keep up with the demand, to keep up with the generations of the battery that has to come to supply. But at the same time, there are a lot of process and equipment and sort of utilizing AI, for example, right now, and sort of machine learning in order to find out and predict the defects that can happen. There's a lot that is happening in the field, but you cannot just put all of your eggs in the basket of innovation. You have to have the little small improvement in order to make sure we can keep up. We can have the process optimization that are needed to push for better energy sustainability, lower the footprint, improve the cost, but at the same time push and have a balance to look into the innovation that comes next in order to replace some of the legacy manufacturing that are existing at the current stage and make that a part of the baseline that everyone is going to implementing. But with what Kenzo and Celina mentioned, if you look into the current manufacturing, a lot of them are utilizing the similar processes. It's just depending on the scope of your chemistry. What is your goal? What is your mission? What is your constraint? And you utilize that legacy manufacturing and then we'll find out what would be the next step that comes either for the traditional lithium-ion battery or the new chemistries that we're working on.
Maybe quickly add something to it. Last 2 years, I have been traveling to China, to Europe, and then also attend a lot of the battery shows. Try to fit it. I also visited, the big factories like at CBTO in the valley, all their kind of suppliers just next door to them. And so all very close, right? So it's a very mature kind of process and very mature supply chain in there, pretty much. And when you look at the supply chain where the battery show in China, that's almost 10 times the European one and the US one, right? It's a much more mature there, right? So as a material supplier and equipment supplier, as in our previous company, we can see, of course, a lot of times in the US, we have a lot of novel ideas, novel kind of chemistries, novel, startups. We are all working on that, right? So of course, there's a lot of innovation related to that, but at the same time, that opens a lot of the new threads that are not supported right now as a chain, right? So that's an advantage of the U.S., but that's also the drawback of the U.S. is that the system is not mature to that level. Of course, you guys are already ahead of most of the people, right? So, but in general, my feeling is that the U.S. still have a long way to go to get that chain together, to bring that supply chain next door, to make things happen much quicker, in a different speed, right? In China, there could be, people say 10 times the speed, possibly. That's sometimes also in Europe. Why the North Pole getting in trouble is that, the supply chain is a little bit remote, right? So that can be a certain issue. If that, going forward, we need to keep these things in mind. Even on the national level, when we build the certain systems, it better build an ecosystem locally, all close together or something like that, from the, design purpose or something, right? So that's just my comments from there. Yes.
You were so to the result. We have a slide for them, a beautiful one. So is there any specific process in the manufacturing funnel that you would say is harder to scale? So when you get there, you're like, oh, damn, not again. Or all of them are equally annoying to scale?
I mean, some of them are more expensive than others, right? I mean, and some of them have longer lead times. Like, it used to be that it took a couple of years to get a coder dropped on your production floor, right? And it's a big, expensive piece of equipment. And it's tough to adjust. Like, once you get that coder, there's not a lot of things you could change about it. If you don't exactly forklift it out of your factory, assembly equipment is a little more forgiving in this regard that, some part of the assembly line is not good. If you planned your factory correctly, you unbolt that piece, forklift it out. If you didn't and you're landlocked, you have to do something else, like put conveyance around the thing to some other piece of equipment. Operating is a different story, I think. I mean, cathode, and you can lose a lot of money on cathode coating very quickly if if you can't line up your coatings properly and you're having trouble getting your coder set up because my coder's running really fast and it doesn't stop and whatever. But if you're in a mature factory, right, you'll turn that coder on and you'll run it for days at a time without stopping, and it'll be really slick and smooth. And meanwhile, your assembly line, you've got stuff going really fast, and you've got a lot of wear and tear on your equipment, and you got to bring it down for maintenance because simply there's just too much spinning equipment, right, that's going on. So it kind of depends where you are and when you are. They're none of them are easy.
Yeah, I think I'll go back to the human factor. I think the scaling of that part, I think, is very, very difficult. Getting the level of the sort of labor pool savvy enough to work on battery line, that's really, really hard. And then the supply chain that supports that, a company that sharpens slitter blades, polishes countering machines, that doesn't really exist in this. The ecosystem's not there. So between that and trying to get thousands of people, trained to become worried about smallest contamination on the line and pay attention to those things. And since that's a scaling problem.
Yeah, plus it's intimidating. You know, you try and bring someone in first time and you put them on a full-scale coding machine and they look at this and they're like, should that? I don't even know where to start. Like, it's huge.
2 stories tall,
Yeah.
100 meters long.
Yeah, exactly. They're like, whoa, right? You know, even a winding machine is super intimidating. It's moving super fast with like thousands of components on it. And like, just trying to thread that thing is going to take you days to figure out. And you're like, wait, which roller does it go around next, right? So, yeah, there's a lot of learnings that have to happen there.
One thing to add, just because I'm working on advanced battery technology, and when you're looking into advanced battery technology, you're in a startup. You don't have that credibility. You're competing against Panasonic and Samsung in the world that as soon as they call a supplier for equipment, they pick up, they give it to you, they give you the price tag, they give you the material, everything you demand, it is given to you. It's much easier. But you're in a startup, you don't have the credibility. Everyone is afraid of what if you're one of those failure history, then you'll become a failure in the history, and then it makes it much harder to have the right price tag, to have the right support system, to have the right team working with you. And you're also having a hard time to have the right team to come and work with you. Just if you're just getting a bunch of scientists and engineers who've been working on R&D level, they don't know what problems to look for. They don't know what is going to be the next step for them. So I feel depending on where you are for the scale-up process, if you don't have that know-how and you don't have that right team and you don't have the right response for the supply chain or the equipment designers that have to work with you, mainly when there's no established equipment out there that you can go, that is off-the-shelf equipment, these are the changes that I'm going to apply, and you have to design with them. That makes the scale up much harder. So if I want to say one part of it is going to be harder, if you're working on an advanced battery technology that is not established, it's not out there, and you're just bringing a new name and you don't have as much as backup, you're going to burn through a lot of money in order to get to the point that you can start having that revenue. And it makes it a really difficult journey ahead of the startup team. Expensive toys that you have to steal from Apple. That's and pay them twice. Makes sense. Rings a bell. I'm going to ask one more question, and then we're going to talk about Northvolt and other startups. When you were bringing your products from lab to Gigafactories, what surprised you? What have you seen or experienced that was most surprising to you? Scrap rate. You can start from 30 to 90% scrap rate, literally burn through money. And that is a main shock that hits the people of seeing, of course, during the ramp up, as you're working through the problems, you will see the reduction to get to the 10%. But the scrap rate is something that no one can believe. Is it the design? Is it the incoming material? What are the process systems? What controllability did I not have? You're transitioning from spreadsheets into the MES and all of the controllability in the process that you need to have in order to better understand the root cause of the problems that you have. And sometimes it is hard to pinpoint one problem. It is multiple things coming together, and you need to move fast while you're trying to keep up with the speed, with lowering the cost, and also improve the quality measures that are needed for your process. And I would say a scrap rate is something that you cannot really predict to know how to bring it down. What would be the strategy? What would be the milestones that you have to drive it? And it's just going to be a work in progress every day, every hour, every minute.
For me, it's always and continues to be the scale of the operations actually required. You kind of get used to it when you work a factory, and then you kind of step away, and then you come back to that factory and just realize how big the equipment is, how much of it there is. It's something to behold when you realize, there's 200 winding machines in this factory. Okay, and just 200 of them all running at the same time, right? And you have to maintain them and everything else. And you have multiple coding lines, and they're all 100 meters long, and there's 8 of them, and it takes you, 30 minutes to get from one side of the factory to the other if you're hustling. And if you want to go and inspect all of the factory, you're going to hike all day, right, to go through all the different processes. And, that scale is just, it always surprises. And the amount of capital cost, the dollars involved, I think surprises everyone, right? The U.S. government, the IRA, they had something like $4 billion to spend. And I'm like, wow, that's less than one Gigafactory, right? Because these projects run in the billions, right? And that scale, I think, it always surprises everyone.
I think what I've been surprised by is sort of the cell-to-cell variability you can see in a batch and the batch-to-batch variability you get. So it's similar to what Asma was saying. The quality of the cell is not always black and white. At the end of formation and aging, there's all these measures that you would do, and some of them fall below for average voltage or something. But does that matter? And you have to check it. You don't want to scrap it. I think that's what a lot of these newer companies that don't have sort of reference points, they end up scrapping everything. It's black or white. It's easy to just scrap it. But having worked in a battery factory, couple battery factories for a long time, you end up with these gray zones. Like, does it really matter if the average voltage is a little bit below spec? Will it affect the customer? I think you have a lot of those excursions, and you have to build up this library of references to get to that yield where you're actually making money.
We haven't get to that stage yet, but when I visited the big factories like Celina, right, so that they ranked at number 9 on the list of global supply. When I look at their quality control team, the whole building, big building, thousands of people. so that's amazing. That's really surprising. Actually, you think that actually last week when we were at the ARPA-E annual conference, we did a calculation. All the electrochemists and the people worked on the in the battery field in the U.S. together is less than the people in CATL. So you eventually can imagine about how much kind of a labor, if they're trained labor, especially in this field, how much kind of a shortage will be if we really do more of this kind of a Gigafactory buildings, right? So it's just to think, how much that could be a very interesting business if the U.S. really seriously take on this kind of battery manufacturing, actually, and training these people, right? The universities, not only universities, even technical schools or something like that. There's a big gap there actually eventually to supply that kind of labor force just for that sector, right? So yeah.
Yeah. At the same time, having done this inside Panasonic, it is very doable. Okay, it is very doable to train people and to teach people how to do batteries. Okay, very doable and very desired as well. Because if you look at the typical operator in a battery factory, in a real factory, this is high-end blue-collar labor. Okay, this is high-value blue-collar labor. It's in fact the jobs that we want in this country for a middle class, right? And they're, manufacturing jobs typically, people think they're low-end. Not in a battery factory, because it is advanced manufacturing. You're not touching the cells. You're taking care of the machine that's making the cells, right? And you have to know how to program it, have to maintain it. Again, high-end blue-collar jobs, high-value jobs, and people actually can learn this stuff, okay? I have watched so many people inside Panasonic who were former, they came out of the hospitality industry, okay? With people that were cleaning hotel rooms. And then, a few years later, they're like awesome coders. They can run a coding line, right? It's not impossible, and it takes a labor force that people that want to work can figure this out. And I had the same thing inside Panasonic when COVID happened. Okay, before COVID, we had something like 300 Japanese folks working with us, and they were all levels, operators through executive area, okay? And, everyone was kind of periodically like, at some point we should do this ourselves without all these Japanese expats here, because it was costing the company a fortune, right? Like they sent these people over and they had to pay them, and they, had these long-term stints. Well, then COVID happened. And all those folks, except maybe a handful, a dozen people or so who were living in the US with their families, they all went back to Japan, okay? And on top of it, we had to shut down that factory, which it's a 24/7 factory. It had never been shut down, okay? It had been started up and running continuously for 4 years, right? So you don't even know what that equipment is gonna do when you shut it down, okay? Like, we were gonna go cold and dark in that factory, like dry it out completely, cold and dark. It took us 20 days to dry out that factory, okay? Like, start to finish. And then we had to start it up again without all those Japanese help, all those helpers. And it was super unclear to us whether we were gonna do it or we were gonna crash all those machines, right? But the truth is that people had been learning this stuff. And, we were like, okay, guys, now we're gonna do this thing and we're gonna do it ourselves and we're gonna figure it out. We're gonna start this thing up. And we started it up and we got it running in the middle of COVID when we couldn't actually be 6 foot next to each other, which is a real trick, by the way, when you're trying to have someone work on a winding machine and two of them are usually climbed in their close quarters together, and now you got to be socially distanced on top of it, right? Oh my God, it was insane. But we got it restarted, okay, and running properly, and then we had to convert the lines to a new cell design, which the Japanese thought was going to be completely impossible. We were going to totally foul it up. They had so little faith in us that they kept buying material for the old cell design. And then after we convert the first few lines, I was so pissed. I'm like, God damn it, guys. Now I have to run out all this extra, material because we didn't have faith that we could actually do this thing. And the truth is, we could do this thing, okay? It was simply a matter of mental focus and saying, okay, now we got to do this. And, that Band-Aid got ripped off by COVID and, we did the thing, right? So, people go, oh, we can't do this without China and everything else. Bullshit, okay? I mean, really, it actually means you got to work.
Inspired by your points, right? So that question actually, would the US be able to run a different model, like instead of the Chinese, like a labor-intensive model, right? So the US has a lot of advantage in AI, robotics and stuff like that, right? So based on what you have done, with that scale, right? So is it possible, we can be more, maybe with robotics, we can be 5 times more efficient with more automation or something like that. Some of the tests, right?
No, I'm sorry. Like, I've heard this thing about the lights out factory, and everyone hoped there was a lights out factory, and Elon didn't put enough parking around the Gigafactory because he assumed it was going to be a lights out factory. It is never a lights out factory, okay? That is because you know what? When you run a machine and you push out billions of cells, guess what? There's wear. All your stuff wears, right? And you don't think about it, but then pretty soon all your sensor surfaces are coated with this fine metallic powder that is floating in the air because simply these tools are running so fast and they're wearing, right? So if, once a week someone's got to get into that winding machine effectively with a Q-tip, okay, and clean every single sensor and make sure every bearing runs, all right? There's never the lights out factory. I don't care how much automation you have. The automation then has to be taken care of. So, no, it's just work. That's it.
It's hard for me.
Maybe a good segue into the Northvolt component. I was there for about a year. I worked remotely. The lights out factory term, I heard there, and that's why they put the factory in the Arctic Circle. It's lights out 6 months of the year. There's no people already, and so you don't need people. And the LFDO now is pretty much abandoned. But the idea was, if Asians can do it with labor, Westerners can do it with automation, and I would say that's one of the things that Northvolt didn't understand quite well, that led to their failure.
Okay, what other things Northvolt did not understand, and what are the rest? Let's learn.
Not enough time
just-
today to go through all.
Just for context, if you're not familiar with Northvolt, it's the Swedish battery manufacturing company. They started in 2016 and they went down last year, officially this year, with $14 billion in debt. So the glorious
$16 billion.
$16 million.
$16 billion.
Yeah, billion. Yeah, billion. Did I say billion?
Yes.
Oh, I'm so sorry. No, billion. Definitely billion. I'm sorry. Yeah. Let's see what happened.
Oh.
Well, I was a part of Qbert, which was a smaller startup that Northvolt invested in, and we were the first one that went down just because Northvolt couldn't make it. But hearing it from some of the insider information, one of the key points was not having the know-how, like not being ready for this, the scale that they have to go. The equipment they have designed did not match the specification that was required. They had the customer. A lot of the failure modes come when you do not have a customer, so the capex that you're investing significantly takes a long time to get to the point that you will have the revenue. That was not the problem. They had the investment, they had the customers, but it was the failure modes and the scrap rate and not knowing how to test and shipping the cells that are not meeting the specification from the get-go. That was like the biggest, or one of the main failure modes, and also like putting the factory in a place where you cannot have the right talent. Any manufacturing requires the right talent with the right mindset, with the right skill set, or if you want to bring them and like train them, that was really difficult, like how they couldn't bring in the right people to the manufacturing side in order to continue that momentum. When you walk, there was a lot of equipment that are up and running. You just see it and like, oh my God, it is amazing to see, to be a part of that journey. But unfortunately, there was a lot of missing point, a lot of failure modes, little by little, that piled up and get to the point that it was one of the catastrophe failures that you see in the market. And hopefully all of us working in the battery manufacturing market can have a lesson learned from that failure mode in order to make the right strategic decisions from the get-go as we're trying to do the site selection, trying to do the equipment selection. What is the right equipment in order to meet the specifications that are needed? And as you're testing, as you're building up the failure modes that was not detected and it just made it to the customers, and you lose the credibility and it just piles up one after the other. That was one of the all other failure modes that happen at both floats. Pick one, not pick the other.
Specification is a good one to start. When they started purchasing their first equipment, the specification was not written by engineers, which is a problem. And the equipment selection was done by procurement folks, because there weren't that many engineers at the infancy. So those are problems. Long list of communication problems, focus problems. I think when they're trying to make their own material, trying to recycle, trying to make cells, trying to make the system entity work, that's a lot of things that you're trying to do all at the same time, and it's hard enough just to make the cells. So there's billions spent on in areas that they probably didn't need to at the time, made to just have to satisfy investors. But yeah, understanding the scope of the scaling problem, poor communication, wrong people in the wrong places making decisions.
Yeah, I think Northvolt, every company that ramps up from small scale to large scale will make plenty of mistakes, okay? The only question is, at some point, the mistakes become too many. It's not about one mistake. It's never about one mistake, okay? And that's the thing. Northvolt made plenty of mistakes, but so did Tesla. Tesla made so many mistakes. We have so many scratches on our bellies from Tesla making mistakes, but they didn't topple the company, right? And Northvolt, just too many. So it's not like people are like, why did Northvolt fail? They want the one thing. There's no one thing. There are many things.
Yeah.
And, Kenzo has a long list. I have a list. My thing is they didn't ask for advice. They went cheap on their equipment. They went to a company that was, kind of new, And they went there because those guys would agree to their terms, and procurement was going pretty hardcore, trying to get the best deal, right? Like, we're going to get the best deal, we're going to do this cheaper, and we're going to do it because the equipment's cheaper. Yeah, you get what you pay for, okay? And I mean, people are like, well, you're going to go spend with, the top-end suppliers. Well, yeah, especially when you're new, because they know something. They've made equipment that is robust, that works for people, and it always works, okay? And you know what else? When you pay that money, you get their advice. If you control your ego enough to actually listen to them, okay? Like, go in there and go, yeah, this is my stuff, and they go, we'd like to try that. Like, we're gonna trial your slurry on our coder. Okay. Be like thankful, right? Go like, sweet, let's go. Take all your engineers over there, sit on their line, let them trial, run your equipment or run that equipment trial and give you advice, right? When they tell you, yeah, this is not gonna work so good or that will work good or something, maybe you wanna listen to them because they might know something, right? And, there was a lot at the time that Northvolt was doing this, there was a lot of feeling, we're more innovative, we're gonna innovate our way to something cheaper, we're gonna, do this better, faster, fewer people. It's like, dude, you don't even know how to do the first thing, right? Like, figure out how to do this thing before you're like going to go and do all this weird innovation stuff, right? I mean, that's how, the Japanese did the thing, right? And they built up this stuff from, long history with like alkaline batteries and primary cells and other stuff. They borrowed from all that knowledge. And they built a line, and then they learned some stuff, and then they built a faster line, and then they built faster lines, right? And then a bunch of them retired, and the Koreans were like, sweet, we're gonna hire all these retired Japanese engineers, which they did, okay? Because the Japanese have this thing where people retired like 50 or something.
They're kind of pushed out at 55.
Yeah, 55, so I'm 55, okay? Right? And I kind of like working, right? So just imagine there's a whole bunch of Japanese guys who have devoted themselves to making lithium-ion batteries pushed out of the company. And then the Koreans are like, sweet, come over here and teach us how to make batteries. And they took their advice, or they bought equipment that was made by the Japanese first. And then they started making their own equipment after they figured out how to do this thing. And then the Chinese did the same thing, okay? The Chinese started off buying equipment from Japan, Korea. They started inviting Koreans and Japanese, especially around a retirement age, to come to China and help them build this equipment, right? They took people's advice, they bought the good stuff, and then they figured out how to make it themselves. Yeah, it's really frustrating when people don't take your advice.
You know.
Gonna have to put it to some, sorry, with just so much. I kind of want to continue this conversation, but I'm pretty sure it's going to go for 24 hours just on Northvolt. But if you go back in time and give your younger self some advice, or there's a lot of young entrepreneurs, parent founders, what would that advice be?
Either ones.
Oh, think for a minute, man.
Well, I can go. We can also take 30 seconds of silence so you can say. To be honest, I think the first advice will be to go after the pain point of the customers and the system, whichever one is that. Just because if there is no pain point and you just try to come up with a solution that there is no customer for it, there's no one out there that wants that, it's gonna guarantee the failure. Once you have that pain point, and then the next step is really the team. I feel we're focusing a lot on supply chain, technology readiness, design for manufacturing, all of those steps. But the main thing that makes the journey an easier journey and successful journey is the right team, with the right stakeholders, with the right mindset. Define your mission and make sure you're having the right mindset with the right people to get you through that journey to get there. And you can have the equipment fail, but if you have the right people on the job to get it fixed and take it to the next level, we can resolve the issues. These are the engineering issues that you can fix if you have the right engineers working on it. And not only the engineers, it's gonna be the pile of people with different mindsets from the supply chain, from the technicians who are working on the line, that all believing that mission, you can align them all and then bring them together in order to get you through that journey. I believe that will be one of the advice I will give myself.
So, by witnessing so many failures in the field, of course, as next generation battery newcomer, right? So of course we learned the lessons early on is that don't scale ahead of yourself, right? So before you kind of solve the fundamental issues or prove the some of the key parameters and stuff like that, under the pressure of either political or your investor or some school or something to that extent, or you try to get markets soon, or try to harvest the stock share, those the investors' money, things like that, can be harmful for the general field in general, because in the past few years, a lot of the bad experience, probably investors has experienced, is that a lot of the technology not been proven yet. But they went on, called the scale, and got a lot of the bad reputations to the field, right? That really harms the field to some extent, right? So what we learned is that stay small if it's still when you solving the certain issues, right? And so while the technology matures, right? So that's something that we learned. Yeah.
I would say that listen more than talk. For me, earlier on, is keep your mouth shut. People will give you information. People will tell you how to do things, and everybody has something to teach you. And the culmination of, I guess, what I know is you talk to people, you learn from people. I think I'm here not because I'm good at dissecting cells, it's because I listened to people along the way and had good mentors and things like that. So I probably didn't do enough of that when I was younger, so that's what I would tell myself, a younger version of myself. Listen.
Yeah, a while ago I would have said skip grad school. But funny thing, the work I was doing for PhD at grad school turns out to be kind of foundational to some of the stuff we do at Lyten now. So 30 years later, I'm like, oh shit, I pulled out my thesis and all the papers, and I'm like, oh my god, I can't believe I'm back into this, right? But that's the thing that I don't like to look back at. I shouldn't have done this, or I should have done something different, because look, the reality is all the things you do shape you, and they teach you things. And if you skipped one of them, you wouldn't be where you are, right? And you wouldn't know some things. I've made plenty of mistakes. I've fallen down lots. Been pushed sometimes, but fallen down on my own sometimes too, right? And but even that, the failures, the things you wish didn't happen that way, they also teach you, and they teach you how to get back up, right, and keep going. I also, a lot of times I'm asked by interns, or I've had a lot of interns, and they're all stressing out about, oh my god, what am I going to do next? What should I study? Which grad school should I go to? Which professor should I work with? And after I tell them don't go to grad school, they still go to grad school. But the thing I tell them is, look, you're going to have 5 or 6 different careers in your career. You're going to start off doing one thing, and stuff's going to change. I mean, batteries were not a thing when I was in college or even in grad school. They were not a thing for a long time. And they weren't even a thing when I first started working, right? I kind of got my first job in batteries after grad school. And even then, I didn't know batteries were going to be a thing. They were this small little bit of, I was doing failure analysis, right? And every now and then a laptop came in and a cell phone, and then pretty soon I, dissected a whole lot of failures, like hundreds of cells, right? Maybe not 1,000, but, right? And the thing is, you're gonna change your jobs. You will. Just go with it. Follow the thing that is interesting to you at the time. I guess the advice would be, don't be boring. Don't plan on being boring. Don't be like, well, I'm going to do this thing because I'll have a job. Wow, that sucks. Okay. Because the thing is, if you're going to have a job that's worth it, it's going to take all your energy and attention. And if it's really worth it and it's really missional, it becomes such, a huge piece of what you're doing. If you don't love it, how you're going to really hate your life, right? So I guess that's the thing. And, it's like, is it fashionable to do the thing that I'm doing right now? Should I do this other thing? I mean, I remember in grad school, like everyone was going to be a business consultant, like McKinsey was on site, and Boston Consulting and Bain and everything. And I'm all, wow, everyone's going to do the management consulting thing. And there's a lot of cash there. And I went and I'm like, I should look at this. And I went to the information session and I listened and I was like, I will want to shoot myself if I may do this thing. I can't imagine wanting, I can't. I just can't. I guess I'm going to be poor. I guess I can't. It was a good call because I would shot myself. But that's the thing is be bold enough not to be boring, right? That would be my advice.
I should party with you, Celina.
Awesome. So Q&A. I feel like you need to have this panel again because I didn't even ask how many questions that I needed to ask, but I'm pretty sure people are excited to ask their questions. So I'm going to open the floor. I'm going to give you the mic. Just help yourselves, each other's.
Hey, thanks, y'all. I wanted to maybe step back from Gigafactory lines to pilot lines and what needs to be thought about when you're designing a pilot line in general? Because I think this is a space that a lot of us just going to be in. And are you thinking, I think they get confused sometimes between prototyping lines and pilot lines. And how much flexibility should be built in? Are you thinking of equipment that you're going to move into a production line? What considerations when you're planning for a pilot line should you be thinking about in that?
For me, the pilot lines, like you said, should have a crop ton of flexibility because you're trying to develop the processes that you might want to design into your mass production. So usually pilot lines have all the bells and whistles, tons of sensors, tons of capability to extract data. That's how I think of a pilot line.
Yeah, if you're a big company with lots of money, that's how you think about a pilot line, right? If you're a scrappy startup, don't spend a lot of money, right? Because you're gonna be, don't get anything too nice because you're gonna be wrenching on it as you change it, right? Yeah, I would say, you got to think about what you can afford, right? And what also, your engineering team, because they will beat on it. How bad is it going to be if they beat on it? If it, a super refined winder, if someone beats on it, it really breaks. Okay. If your winder's kind of crappy and, someone beats on it and then you go, well, the tank, we got to buy a new mandrel because we bet one. Okay. Let's buy a new mandrel. But you have to consider also where, what your business is going to afford because you're going to live with that pilot line for a long time. You think it'll be a short transition, but it will not. Because your boss is going to come back to you and go, I want you to produce things off of that. I want you to produce lots of things off of that. You've got to become a profit center. And you're like, damn it, I didn't plan on that, right? Yeah, you're going to have to live with it.
When you're scaling up your manufacturing, I'm wondering if you could walk me through your logic around how large of a throughput increase you want to make in the next generational leap, and then how much you want to shoot for the most ideal, perfect, optimized process, balancing it against technical risk.
No idea.
I mean, this comes down to you look at your boss, and you look at the investors, and you're like, okay, you're gonna have to satisfy them somehow, right? So, it comes also to, it comes down to your individual situation too, right? Again, if you're at, if you're at a big cell maker, right? And you've already got revenue and, you can afford to do things a little more incrementally, you'll do them a little more incrementally, right? You're not gonna take a huge risk, but you're gonna say, well, okay, this is the timing that I need to hit. So I'm going to make something roughly this size. I'm not going to make giant leaps because I don't have to, right? And then I can do the next factory after that. If you're a startup where, you're under a lot more pressure, you're going to aim for something bigger just because your investors are going to require it. I mean, in the end, you're going to put a CapEx plan together, you're going to show it to your boss, and you're going to go, this is going to do X. And they're going to be like, yeah, the investors will go for that. Bigger, right? And so, that's a bit of a trap, and probably also a trap that Northville fell into, that, there's a lot of push to go bigger. Yeah, you got to be bigger, and the revenues have got to be bigger. So usually you're at that point trying to haul it back in and kind of go, could we go smaller, please? Just at least phase 1, smaller. After phase 1, we go bigger in phase 2, right?
One recommendation is, as you're trying to transition, if it's from lab to Gigafactory, I think that pilot line plays a significant role, that you do a lot of validation. That is going to be your playground. Use your playground to learn a lot, to know how much you can push it, how fast you can move. Otherwise, you're going to just, with all of the unknowns that is in front of you, just because you were successful in lab scale, you believe into something much bigger than you can actually comprehend and you can actually execute on. So I would say the pilot line phase is really important to navigate, to do the have the know-how, and just reiterate, fail and reiterate in order to learn. Then you can have an educated understanding of how big you can go. And of course, it is really important to know, are you working with an established chemistry? Is it an advanced biotechnology? What are the environmental constraints? What are the supply chain constraints that are existing around you? And it takes a lot of research and a lot of studies in order to better understand and have the data collection, get the advice of the people that have done it before, in order to know, based on the constraint and the budget that you have, the expectation that is in front of you, how fast you should go and how big you should jump the leap as you're trying to transition. But I always believe in the phase gate. Like, there should be a phase that you have a go, no go, and then you take it to the next one, but you cannot just spend too long in that phase in order to make sure you have that success story. Otherwise, you're going to not be competitive and you're going to just fall behind.
If you're a startup that makes a battery component and you don't want to go into battery manufacturing, what are the most important things you think should be tested to make battery manufacturers want to use your component, because they're not going to just trust that it works?
As a startup, we used to be a component company, right? So just make the materials, right? So, of course, they always want you to test and test, right? So, because there's a lot of factors, right? So those big companies, those employees have their own egos and stuff. They always think their thing is the best, right? So, so there are a lot of barriers there to overcome those kind of the ego and the internal decision-making processes, right? So of course, that's why actually that forced us to do some like a internal kind of a cell development to demonstrate the cell performance. A lot of times when they saw the data, they may think differently, right? So you may just have difficult time to convince them just with the component, because sometimes it might be too novel, right? So the status quo might be too good, too strong, for them to risky for them to test or something like that, right? So, at least from our point of view, when we show the data, the cell performance in our lab, they're impressed, and then they will open up for further testing, right? So, and also, internally, when the kind of the internal employee that kind of ego thing pops up, but the data is there, right? So their boss may ask why they can achieve, but you cannot achieve, right? So that may help at some point to cross the barrier, but there's a long journey still as a startup, but we feel the pain there. Yeah. So.
I think depends on the component. But I think there's 3 pillars that battery companies look for. It's performance, safety, and cost. You have to be as good or better on all 3, or one of the 3 aspects, and not compromise on the other one, because they're not going to buy it if it's not if it's more expensive, they're not going to buy it, obviously. And if it has to be at least safer, that's almost a given. And there's got to be a good performance benefit. But again, depending on the component or material, there's compatibility. Does your component affect the other components? And those have to be well understood and tested. And they don't want to test that for you either. You have to have your own data to suggest that it's at least interesting enough for them to sample, because battery companies have their own projects going, and they're always cycle limited or channel limited, and resource limited. So there's a lot to it, for sure.
Or one more channel would be like a third-party testing results that just show is probably more, kind of objective in that case, right? So maybe help to build the trust there. Sometimes we find that, and then, our customers, they publish on that nice paper, right? So, and then the customer will come to us and say, oh yeah, I saw this paper, maybe something like that. Then, so over time, build that database. Why?
Okay, I'll go next. I have a business angle question, but sure that I'd like to congratulate you, Sama. The World event is getting bigger and better every time I show up. So congrats.
Thanks for showing up.
No problem.
That's still legit.
I have a little different angle to the discussion that we must have, is from a business perspective. As you know, based on our tally, there's more than 700 gigawatt hours of a capacity already built in the United States. And out of that, based on our intel, there's only about 30 at max that's in operation, meaning that the demand is not there. Even for the major applications like EVs and ESS, for ESS, and the demand is there, you just don't have the cells. So from the startup's perspective, obviously you cannot compete with those already built 700 gigawatt hours to commence. And then not every one of us can go after the DoD money and say, hey, defense, that we can just compete against ourselves. So what should be the game plan for the US startups?
Sure. Okay, so first off, you got to think in the timelines too, right? So when you look at the demand that's actually the demand that's brewing, okay? Because I don't have a gigafactory right now, right? I can supply a few hundred cells a month. Great, that's not a gigafactory. I have to start the business, and I have to get to a point where I get to build that factory, and then I'm betting on, okay, there's got to be a market for it, right? And what am I aiming for? And so I do have to size it to the business that I want that factory to supply. Okay, and people always say this: oh, there's lots of factories, there's lots of capacity. Go try and buy some cells from those factories. Really, go try and buy some cells from those factories. Most of them are spoken for, right? They're tied to one automaker or another. And you want to buy some cells from Panasonic's factory in Reno? Good luck. There's no packaging line there. You can't buy them. So they're not available to you, right? And they're not available to a lot of customers, okay? And you come up and you say, well, I've got cells, and people are like, sweet, I'll buy them, right? Because more and more new products, more and more industries are getting into electrification. So you need to consider that. Now, the U.S. automaking thing in the EVs right now, yeah, that's kind of turbulent and kind of a mess. No one's figured that one out yet. At the same time, the Europeans are full on into electrification. And, the U.S. automakers may be accepting the fact that they can go build V8s that they think will sell for a little while, but they all know that if they don't have a good electric option, they are not going to be around in 10 years. So they may be like, I don't have to make all those EVs right now. But they're planning that they have to make those EVs, okay? In the meantime, all the delivery vehicle guys, nice little business, not too big, small gigafactory, yeah, that'll supply that. All the micromobility stuff, also booming market as more and more people go electric and, get on these scooters and bikes and stuff. And then the stationary business is just rocking and rolling. Everyone is looking at electrification and power and grid resilience and right. And every country that's coming up developing economically, people want the electric appliances, right? And you're going out somewhere remote and people want a good source of electricity. They don't have all that copper. They don't want to put in all that infrastructure that they're going to run all that power out to some rural area. Much easier to put a big solar array out there or some other renewable and have grid storage attached to it and provide power, right? So the demand for that's just getting started. And when then we talk about like AI, which is sucking up power, right? And you've got people out in Nevada putting out these huge solar fields and battery storage to run their data centers. Like, there's a lot of business out there, right? And there's still plenty of demand. And, you know, the things that you're going to use for an ESS, they're not the same as an EV. So even, you know, like the ESS guys are like, you have cells? Really? We'd be interested, right? So, yeah, there's plenty of market out there. You do have to go look for it.
Just a comment.
Just in part.
Right now, of course, based on the political environment right now, EVs has become the evil words right now in DC pretty much, right? So, you know, a lot of the funding getting held up and it dried up and things like that, right? But if you think about battery, it really shouldn't be bearing that name because that's really kind of a national interest to some extent, right? So, because you recently you hear that China pretty much cut off a lot of the drone companies' battery supplies, right? So, and also we would talk about AI, where, you know, the robotics in the future, you know, the AI eventually physically, you need to be involved in your life. They cannot wear a tail in your house or anything. They all need to be, you know, rely on batteries. As a country, this is something strategic, you know, EV or not, that batteries need to be manufactured in the US, right? There should be enough incentives for this kind of factories to target different applications here, at least, yeah, so for different sectors.
So we've talked a lot about the context of workforce of the engineers and technicians operating on the factory floor, but leadership is also critical here. What are the critical qualities for battery leaders that you think are both that you would look for in, say, your next leadership level hire? And would those differ at, say, a lab scale, trying to go up to a Gigafactory versus an established Gigafactory?
The main thing in leadership is decision making. There is a lot of failures that are due to the failure of a leader at the point when they are collecting the data, and then they need to make a decision with the right stakeholders being involved, with the right information provided. If they fail to make that decision, the engineers, the technicians who are trying to get the job done don't know which direction they go. And then that's when everyone is running around trying to do whatever they think is the right one, and then it makes it hard to bring them all together. So in leadership, the power to the leadership is to make sure they have the right insight, they have the right inputs, and then they are able to make the decision and pull the trigger when it's needed. And a lot of the time they just kick the can down the road. Let's cross the bridge when we're there. You're there. You just don't want to see that you need to make that decision. Rip the Band-Aid. This is going to be the decision you have to make today. And then make sure your engineers are aligned. You are having the right communication with your engineers, with your team, and have them to believe in the mission. That will be the steps that you have to take in order to have the strong leadership. Otherwise, there's not going to be no decision, there's not going to be any alignment, there's not going to be right communication, and then everyone is just going to go and in different directions, and no one can really get to the main point and the goal of the company.
Yeah, I look a little differently, and you know, being able to make decisions is crucial. But when I look for leadership in a battery team, I'm looking for someone who is going to be able to drive heavy collaboration, because batteries are so complex, right? And you have to have all the different groups working together, because you're really basically conducting a symphony, okay? They're all the different instruments and they have to all line up, right? And all be on pitch and all be in the same place. But what does that mean? That means that everyone's breathing together, right? And if you sing or if you do like wind instruments, you see everyone breathes together to hit the notes together. And that kind of collaboration has to happen, right? Everyone's kind of got their own thing to do, but they have to be able to be with the other people and understand each other. And I feel also that, you know, for us, where we're trying to ramp a new chemistry and commercialize it, the hardest part, the trick, is to pull R&D in with the manufacturing production team together and have them interacting together in a positive way, which is so hard because they're very different mindsets, right? In the R&D world, it's all about the creativity and, and like the innovation, and it's super chaotic, okay? Because that's how you get a lot of that innovation, right? You just, bounce things off each other, and all the chaos and schedules are sort of kind of important, but not really, right? Okay? And then meantime, your manufacturing team is entirely about order and consistency, and we're doing this and this and this, and schedules are everything, right? And meeting your numbers are everything. And the two approaches tend to be very different, and there's people can't live usually in one side or the other. They firmly in one camp or they're in the other camp. You have a hard time communicating. So from doing a battery, you have to have that deep trust and communication between these people who are on the R&D side and on the kind of the electrochemists who understand the chemistry, and the creative types, and the manufacturing people. That's a hard skill to find, but that's where I look in leadership, that someone that's going to be able to cross over that and work with their counterpart who might be in R&D, right? Because it's well, I need to do this new thing, and the production guy goes, that sucks, it's never going to work, right? You're going to make me do that? Or they come back and they say, I tried that, our yields are shit. I don't want to do that, right? Because the production guy is all about his numbers, right? It's I didn't make enough cells because, your coding was too fussy, right? And, you can end up in a war, right? Really fast. And what you have to do is you have to step back and say, okay, looks like we need some more engineering resources on this thing. We got to figure out how to do this because this is the future. And you got to be able to drive that mutual respect and understanding between those groups.
Good luck doing that.
The one thing to add is we don't scale up the battery manufacturer, but we do scale up our production. Sometimes I feel that as production, you're already out of the R&D stage. As a leader, you have to be firm on things. Otherwise, because if you depend on your hire, right? So in the US, it's kind of lack of those people who get an extensive kind of scale up experiences. When you hire someone from academia or any other, places that they haven't experienced that scaling up, they tend to go back or poke around for other things, right? So they want to try different things. As a leader, you have to be firm. You already gone through this stuff, so you don't want to go back. You have to be firm, focus on the direction you are headed to. That must be product focused. The SOPs and the procedures must be fixed to some extent, right? To narrow that down instead of poking around. You're already out of phase. Cannot do that anymore. Yeah. So unless that's proven something wrong, then you have to do something. But otherwise, that's already proven, already tested, already customer confirmed. You cannot do much of those things. Everyone must be aligned. Some dictatorship on there, to be honest. And kind of that R&D level of openness and those innovative stuff must be got sometimes. Yeah. So.